Welcome to November 24th LeetCode Challenge. Maximum number of coins you can get. There are n piles of coins of varying size. You and your friends will take piles of coins as follows. In each step, you will choose any 3 piles of coins, not necessarily consecutive. Of the choice, Alice will pick the pile of the maximum number of coins. You will pick the next pile with the maximum number of coins, and your friend Bob will pick the last pile. Repeat until there are no more piles left of coins left. Given an array of integers piles where pile index I is the coins in the ith pile, return the maximum number of coins you can have. So say we're given the number array here piles here, and we need to pick a triplet or pick a triplet of coins here that we could pick from. So say we pick the numbers the coin piles 2, 7, and 8 as given here. We know that Alice will pick the first one being 8, we will pick the second one being 7, and then Bob will pick the last one being 3. The remaining values are 1, 2, and 4. Alice will pick 4, we would pick 2, and Bob would pick 1. And that gives us a maximum total number of coins of being 7 plus 2, which is 9, which is our output. There's another note. What if we picked not those triplets, but we picked, for instance, triplets first triplet we say we pick 1, 2, and 9 and 8, and the second triplet we pick 2, 4, and 7. That would actually give us 6 coins in total, which is not the maximum or not the optimal number we want. So keep that in mind for now. We'll move on to the next example. If we have a triplet to begin with, we know that right away Alice is going to pick 5, and we're going to pick 4, and Bob will pick 2. Our output will be 4. And then this example here, we'll go over this a little bit later. This will be 18. I'll tell you why later. So the constraints that we have pile length being between 3 and 10 to the 5. And the length of piles is a divisible number by 3. So it's always a multiple of 3. Index of piles is between 1 to 10 to the 4. And how do we go about solving this? So we don't actually need to stimulate the process because our choice is pretty much the same each time if we were to optimize it. How is that so? So if we were to take this example here, numbers range between 1 to 9, let's sort it out. So say if we're given an array and we were to sort it first, as such. It doesn't really matter what the array is, as long as it's sorted. And we were to work a little bit backwards and say, hey, who would choose these numbers, right? So we know that each time that Bob will always pick the nth smallest pile from the remaining and Bob will always pick the smallest pile. And say 9 is divisible by 3, so that means that everybody will pick 3 piles minimum. And we know that everybody needs 3 piles, and therefore the smallest number is always picked by Bob. Bob will get these. So let B represent the Bob's pile that he picks, and Bob will always get the first third of the smallest pile. And then we would also pick. So Alice will always pick the largest one, followed by us being the second largest one. So with that being the case, we can always work backwards. Or if Alice picks first, we pick second. Then we know that we pick last after Alice. So therefore, we say let U represent us, and us we will pick 4. Alice A represents Alice. Alice will pick 5. We would pick this one. Alice will pick it again. Us would pick this, and Alice pick this. So notice how there's a little pattern there, right? So the first third of the sorted array will be chosen by Bob, and from that third, moving onwards, it'll be us, Alice, us, Alice, us, Alice, us, Alice. So Alice will always be picking the largest number, followed by us. So of the remaining pile, Alice gets the largest one, then the second largest one will be picked by us, then Alice will pick the third largest one, and then the fourth largest one will be picked by us, and so on. So if we sort the piles, we get the following pattern. So far we know who gets picked what, and let's kind of leverage this kind of pattern to our solution. By the way, let's kind of solve this. So if we were to pick out the numbers, so we pick 8 plus 6 plus 4, which is 18, which is the output. So we know that kind of works in a way. As such, we could find the piles that we claim by iterating through number of piles. We will start at iterating over the index n, as the first pile is after Bob picks the pile. So iterating through two indices at the same time at a time, as every other index is picked by Alice. So we have to iterate through this kind of carefully. So in order to pick the right pile that belongs to us. So recall that the problem description states the length of the array is given as 3n, and that is to say we iterate through index n, right? And let's kind of go about solving this. So first thing we want to do is sort the piles. How do we sort the piles? We could use array dot sort piles. Keep in mind this is Java, so it would be big of n log n. Just something to point out later. Int, we have to initialize our answer, so call answer equal to 0. And here's our iteration step. So for int I, and this would be the length of piles, dot length. So it would be given that 3n piles of coins. That means that length of piles needs to be floor division by 3, right here, because we're iterating through the 1/3 of it. While I is less than piles dot length, we want I to be incremented by 2 per iteration. We want I to be incremented by 2 iteration as each 2 indices, we iterate 2 indices at a time because every odd index is chosen by Alice. So we need to increment by 2. So this is our iterator, our iteration step, which looks a little bit, out of the ordinary, but something to keep in mind. So for each time we iterate through, we pick our pile, and we obviously want to accumulate our answer as piles at index I. And then when we exit the loop, we want to return our answer. So this should give us a good go. Let's take a run. So it seems like it's good. And accepted. Awesome. So so since we use Java, the arrays.sort is big O of n, log n. We also iterate through it n times as well. However, so the overall time complexity is big O of n log n. Space complexity, depends on the language you use, but arrays.sort is a primitive implementation of quicksort, so it does solve it at a big O of log n times. So yeah, that is it for space complexity. That is it for today's question. Have a great day.